Hey guys, good evening. Am I audible? Okay. All right. So let us start with the session. So we were discussing things with respect to the memory allocation in the previous class. But before the memory allocation, we had things to be discussing about the string. Initially, we started with string, and even before that, we started discussing how to pass an array from one function to another function, how to collect an array from one function to another function, how to access the elements of the array being in another function. So after that, we saw what a static keyword does. Then we looked into what is a recursive function. We understood a recursive function with an example. Then we got to know things with respect to the segmentation fault and the wild pointer, the const keyword. Then we did the strings. So we understood how to do the initialization of the string and what are the library functions associated to the string. Then we started with storage classes. We discussed things with respect to the memory segment. So every operating system will have a memory which is split it into two sections. One is the user space, the other one is the kernel space. So any number of processes running will be either running in the user space and the kernel space. So all the process which are associated to the kernel will be running in the kernel space, and all the process associated to the user will be running in the user space. Now, we being the users cannot access the kernel space as it is restricted to the super user or the administrator. So if we try using the kernel space, we end up getting an error. We are trying to violate the rules of the memory, and we are not supposed to do that, which is why you will end up getting an error scene when you see the access being done in the kernel space. So let us concentrate on user space more. And in case of user space, every process which is running will be available in the user space. And to every process, there will be certain bytes of memory allocated. So when you execute your C program, that also is a process which is running in your device. And that process also gets certain bytes of memory allocated. Now, the memory which gets allocated for a process can be split into four segments. One is text segment, then stack segment, data segment, and heap segment. So, text segment is something which is at the bottom, which is going to have the code stored inside it. Data segment is the one which will have global variables and static variables stored. All of the global variables which are initialized will be returned in the initialized data segment. All the global or static variables which are not initialized will be available in the uninitialized data segment. Now, after the data segment, we have as the heap segment, which is used to do the dynamic memory allocation. So we have something called as the memory to be allocated dynamically, which happens in the uh, uh, heap segment. And we have is the stack segment. So whenever a process is running, for a particular function, there will be a stack frame created in the stack segment. So after this, we had to start with the types of the variables. Okay. So we actually have got different types of variables. So remember one thing, that whenever you declare a variable inside a function, so it doesn't matter whether it is in a main function or it is in a user defined function. Now let's say I take a main function. So inside the function, if I declare any variables, so int x comma y, something like that, they are considered to be the local variables. Okay. So similarly, if I look at the fun function, so if I write fun function, so inside this function, whenever I declare a variable, they are considered to be the local variables. So for example, int a, then I say float y. So all of these are local variables. So they are visible only to that particular function. Out of all of these functions, if I declare a variable, so a variable you don't declare inside a function only, you can do it outside all the functions you are writing. For example, I say int num here. So this num is being declared outside all the functions. Okay. Is there a disturbing noise? Can you please confirm others? Is my voice not properly audible? Okay, give me a second. Let me check. Okay, is it clear now? Can you hear me properly? Okay. Some child's noise. Okay, some kids are playing around outside, so maybe that was the noise. So I've closed the windows. Okay. So I think now it is fine. So let us continue. So coming back to this, yes, I was saying that whenever you declare a variable inside a function, so you call it as local variable. So you have one local variable in the main function, as you can see here. So I have declared two variables in the fun function. Any variables you declared inside a function, you call it as a local variable. Now, if you declare a variable outside all of the functions, they are called as global variables. Now, the reason for us to take a global variable is this global variable should be made available throughout the file. Okay. So I want this num to be used in main function. I want this num to be used in fun function also. So global variables are meant to be used throughout the file, in fact, throughout the program, but local variables are meant to be used only in that function itself. So x and y, if you are seeing here, should be used only in the main function. A and y, if you are seeing here, should be used only in the fun function. So local variables are restricted, and these are global variables which are available throughout the program. Apart from that, whatever functions you collect into whatever arguments you collect it into a function, let's say you collect n1 and double n2. So I'm generally taking int n1 and double n2. They are called as formal parameters or formal arguments. Okay, so you call it as formal parameters or formal arguments. So we have three types of variables: a global variable, a local variable, and the formal parameters. Okay, so we have all of these global variables, as I said, will be visible throughout the file, and it will be visible throughout the program. So local variables will be visible only into that particular function. So now what happens with this is, in case of the local variable, to these local variables, okay, so global variables are the one which will be visible throughout the function. So I can use num inside main function, I can use num inside fun function also. So they are global variables. So whenever you are taking the variables, to these variables, you can add some keywords along. So for the local variables, you can use three keywords. One is auto, the other one is registered, and the third one is static. Okay. So to the variables, you can add auto or registered or static to the local variables. To the global variables, you can add static and extern. So either of the two. So you can either use static or you can use extern. So remember, these are the keywords which can be used on the variables. So for local variables, you can have auto, registered, static. For global variables, you can have static and extern. So here is a table which tells what happens when those keywords are used. Now, auto is something which is always applied on local variables. Okay, so this is always applied on local variables. Now, all of these three are local variables: auto local, register local, static local. So, all of them are local variables. Now, because they are local variables, you can use them only within the block or within the function. So all the three things, whether it is auto local, register local, or static local, they have to be used only within the block or within the particular function. Now the lifetime is the moment you enter the function, the variable gets created. Once you come out of the function, the variable gets destroyed. So three are local variables. One is auto, one is registered, one is static. So it's something like this. You can take, for this you can have a auto keyword added, or you can have a static keyword added, or you can have a register keyword added. So for the local variable. So you are seeing what happens when these things are used. So whenever you are using auto, register, or static, because they are local variables, they are visible only in the block, means inside this flower braces, or it is visible only to that particular function. So the variables will be present from the moment function is called till the function is executed. That is for auto and register. But only static local variables are going to stay until the program gets terminated. Okay, so static local variables are going to stay until the program gets terminated. Now auto local variables gets the memory allocated in the stack segment. Register local variable gets the memory allocated in the register, and static local variables gets the memory allocated in the data segment. Now we already know stack segment. So whenever a function gets called, a stack frame gets created. So auto local variables get the memory allocated in the stack itself. Register local variable gets the memory allocated in the register. So register means it's a memory which is close to the CPU. So whenever you are going to use a variable for more number of times, if you are using a same variable for multiple number of times, then you consider such variables as register local variables, and you will get the memory allocated for these variables inside the register, which is a memory close to the CPU. So that is register. So register local variable gets the memory allocated in the register which is close to the CPU. Whichever variable you access often, you can consider them as register local variables. Then static local variables are the one which gets the memory allocated in the data segment. So data segment, you already know there is initialized and uninitialized data segment. So static local variables will be available in the data segment depending on the initialization you have made. So if it is not initialized, memory is allocated under uninitialized data segment. If it is initialized, it will be written under initialized data segment. And static local variables are going to be present until the program gets terminated. Then after this, we have static global variables. So to the global variables, you are adding a static keyword. So static global variables are going to be available throughout the file. So whichever file you take, static global variables will be available throughout the file from the entry till the end of that particular program. Okay. So it will be present. It will be visible only to that particular file. Okay. From the entry till the exit of the program. And because it's a global variable, memory will be allocated in the data segment. Now, extern is also something which is applicable on global variables only. So the visibility of extern variables will be throughout the program. So you can write a program using multiple files. If you declare a variable in one file and you want to use it in another file, you will use it with the help of extern keyword. So these extern global variables will also be available until the end of the program in the data segment. So these are the keywords I would say which belongs to the storage classes for the variables you are trying to create. So for the function, sorry, for the local variables, you can have auto register or static keyword appended. For global variables, you can have static or extern appended. Is a file same as a function? No. So file means it can have multiple functions returned. So a file doesn't mean a function. So file means a complete file which can have multiple functions returned inside it. Okay. Now we observe the examples here. So these two are global variables. This is an uninitialized global variable. So memory is allocated under uninitialized data segment, which is also called as BSS. And then a file and a program both have multiple functions. Yes. So program means it can be made up of multiple files also. Okay. A program can be made up of multiple files also. So all of these three variables which are declared outside the function, okay, so they are called as global variables. So BSS stands for block started by symbol. So BSS stands for block started by symbol, which means uninitialized data segment. Another name given for uninitialized data segment is BSS. So first one is an global variable without initialization. So the memory is allocated under BSS, which is uninitialized data segment. Second one is a global variable initialized with the value 10. Hence, the memory will be allocated under initialized data segment. Third one is a uninitialized global variable with static keyword. So memory has to be allocated under uninitialized data segment, which is BSS. Fourth one is an static global variable initialized with the value 10. So memory is allocated for global 4 under initialized data segment. Then local one is a normal integer local variable. So memory will be allocated in the stack segment. Okay, so memory is allocated in the stack segment. Then static int local 2. Local 2 is a static local variable. Because it is uninitialized, memory is allocated under BSS. Then static int local 3. So local 3 is a local variable of type static. So because it is initialized with 20, memory is allocated under initialized data segment. Register int I. I'm using I again and again, so I'm taking it as register. Register int I is a local variable. Memory for the register will be allocated in the registers. Ma'am, where we want to do the assignment. So it will be instructed. You have to wait. Okay. Auto. So auto means it is just a local variable. So even if you write auto or you skip writing auto, doesn't make any difference. You write auto or you don't write auto, it doesn't make any difference. So if it is auto int local 1, so local 1 is just an local variable which will get the memory allocated in the stack segment. Ma'am, how do we connect different files to create a single project? So while compiling, you have to compile all the files together. It will give you one executable file generated. So while you are executing your program, even if you have written your program in multiple files, all of them will be compiled together to give one executable file generated. So you execute that executable file to see the output. Difference between global and static. So static is like a keyword which is applicable on global variables. It can be applied on local variables also. The difference between static global and static local is static local variable will be visible only to a particular function because it is local. Static global will be available throughout the function, but for that file only. You cannot use it in the other file. So that's the difference between static local and static global. What is stack? So stack means stack segment. It is the topmost segment of the memory which gets allocated. So every function you call, there will be a stack frame getting created. Now here what I'm trying to do is, okay, so global variable, if you can see here, any variable which is declared outside a function is called as a global variable. Whether we can declare the variable as global inside the function explicitly? No. So global variables should always be declared outside a function. So if you can see here, I have taken a variable called num as a global variable and it is always declared outside a function. So only if a variable is found outside a function, it is considered to be a global variable. Else it will be a local variable only. So all the global variables will be declared outside a function. So here also num is a global variable declared outside the function and I can use this num anywhere throughout my program. So extern is a keyword which is used to bring a global variable from one file to another file. Why should we use global variable? As I said, you want one variable to be visible to all the functions. You need a global variable to be taken. So extern is a keyword which is used to bring a global variable from one file to another file. And it literally can be brought for any number of times. So here extern int num says I'm bringing num1 from another file. Again, extern int num1 says I'm bringing num1 from another file. So extern will always say that you are bringing a variable from another file. The extern is always meant to bring a global variable from another file. Okay. So using extern, I'm bringing num1 from another file. So then I have a declaration of the main function made. So I'm telling the compiler that I have written a main function. So this is called as the declaration of the main function. Then I'm writing the main function with two values. One is int, the other one is char. So I have two integers num1 and num2 which are local variables. I have one character called short option which is also a local variable. So I have got two variables num1 and num1 which has been brought from another keyword. So we will see one more example here. Okay. So just observe that extern is a variable which is used to bring a extern is a keyword which is used to bring a variable from one file to another. Now here is a simple example you can notice. So first I have the headers inclusion done. Okay. So why do we declare main function? That is not required to declare a main function, but that is not even an error. So you can declare a main function also, that doesn't give you any error. So just informing the compiler that I have written a main function. Okay, so to start with, I have a function called main function and two more functions, func1 and func2. So assume I have written in three different files. I have file 1, I have file 2, I have file 3. So main function is written in file 1. Func1 function is written in file 2. Func2 function is written in file 3. So I have got three different files to have three separate functions written. So there is no rule that all the functions have to be written in a single file itself. You can have the functions written in any number of, in any file. Okay, so here also we are trying to write a function in different files. Okay, so we are trying to write a function in different files. So what happens here is, first to start with, I have a global variable declared called num. So I call num as a global variable because so I am using it outside all of the functions. So the variable is declared outside all of the functions. So I have declared it as a global variable. Now you enter into the main function. There is while of 1. So while of 1 means the condition is always true. So the loop is going to run for infinite number of times. So in place of condition, if you have 1 return, that represents the condition is always true and the loop is going to run for infinite number of times. Okay. So I'm showing you the example of extern. Please pay attention. Okay. So what is the difference for int main with and without comma? So it is semicolon. So this is called as the declaration of the main function. You are not writing the definition. It is just the declaration. You are telling the compiler that I have returned a main function. And this is the definition of the function. Okay, so this one is the definition of the function. This is declaration, this one is definition. Okay, so I have an integer variable called num here, which is taken as a global variable. And global variable's initial value will be 0 by default. So I have taken a variable called num, which is a global variable having 0 return by default. Then you go with while of 1. So the loop is running for infinite number of times. So num plus plus, so 0 plus plus, the value of num is 1. Okay. Now I'm calling func1 function, which is written in a separate file. So here is the func1 function. I want to access num being in another file, and the num is already declared in file 1. To bring this num to another file, you are going to make use of extern keyword. Okay. To bring the variable num from file1.c to file2.c, I'm going to make use of extern keyword. The num variable is brought to this file also. Okay. So by default, num will be initially 0. So how means that is how it has been designed. All the global variables by default will have a value 0. Okay. So it is 0. I'm doing num plus plus, which updates the value of num to 1. Func1 function gets called. So control will come here. The func1 function is written in a separate .c file. Okay. So it is written in a separate .c file. So here to use the variable num, which is available in a separate file, I have to bring it to this file with the help of extern keyword. So extern is a keyword which is used to bring a variable from one file to another file. Okay. So I have got func1. So now I print the value of num1, which has been updated to 1. So I am going to print 1 as an output. Then return 0 is going to return 0 to this place. Sleep of 1 will induce a delay of 1 second. Okay. Sleep of 1 is to give a break of 1 second. Then func2 function is called. So you are at here, the file number 3. I again want to use num here, which is declared in another file. So I am going to bring it with the help of extern keyword. Okay. So I'm going to bring it with the help of extern keyword. Again, I'm printing the value of num. So 1 will be printed as an output. Then you come back because you are in while of 1. Num plus plus will be updated to 2. Again, func1 function will be called. You print the value of num as 2. Sleep of 1 will give you a delay of 1 second. Func2 function is called. It prints the value of num as 2. So this continues for infinite number of times. So the output of this will be num is 1 from file 2, num is 1 from file 3. Num is 2 from file 2, 2 from file 3. So always if you want a global variable to be brought from one place to another place, so I'm going to make use of the extern keyword. If we not initialize the global variable, then default value is 0. What in case of local variable? Okay. So in case of local variables, the initial or default value of the variables will be garbage. That will be some garbage value. How does file 2 and file 3 will be known that the int num1 is from file 1? So while executing, you first compile file 1, then you compile file 2, then you compile file 3. When extern is searching for a global variable, it finds a global variable which is available, which can be brought into another file. There is one global variable which can be taken to any file. So it doesn't matter where the num is. It just has to be outside the function. It has to be a global variable. Extern can bring a global variable from one file to another file. How will file 1 find func1 function? So I will compile that way. So if when you compile, all of them will be converted to one executable file. You will execute and see the output. Can we take sleep function? Is it required import time? So sleep is a function which is just giving a small delay of 1 second. Sleep of 1 is giving a delay of 1 second. You observe the output now. I'll show you. So first I'll copy this main function. So this is your main function. Okay, so this is your main function. Then I am creating one more file. Okay, so I name it as file1.c. Okay, so in this file1.c, I will have the definition of this func1 function return. So I'm copying that func1 function. Okay, and having it return here in file1. Okay, so I am trying to indent. This is file1. I will create one more file called file2 .c. Okay, and we have to write the contents of file2. So these are the contents of file2. I'm having it return in file2. Okay, so tab space, a tab space. Okay, so this double quotes are not properly highlighted. So this is the double quotes. Okay, and this also. So here is the double quotes. So whenever you want to bring a variable from one file to another file, so you are going to make use of extern keyword. Now observe the output. It says num is 1 from file 1, 1 from file 2, 2 from file 1, 2 from file 2. So 3 from file 1, 3 from file 2. So it is going to print it this way with a small delay of 1 second. Okay, between the statements being printed, there is a delay of 1 second. Okay, so that is how you bring a variable from one file to another using the extern keyword. I hope you got this. Okay, so that was about the global variable. All the files need to be in the same folder for it to work. Yes, so they all have to be compiled together. They have to be executed together to make sure it is working fine. Is it mandatory to give function consisting file name only main.c? No. So it need not be the name as main.c itself. File name can be anything, but preferably extension has to be .c. Okay. Yes, so that was about the global variables. I hope you got it. So the next we have got is to discuss things with respect to the preprocessors. Now, have you been seeing the very first line we have ever been writing is ash include stdio.h. So have you observed that? Have you observed that the very first line we write is ash include stdio.h. Now, ash include, yes, it is a header file. So we are trying to include a header file using a preprocessor directive called ash include. So ash include is something called as a preprocessor directive, which is used to include the header files. Now there are two reasons to include a header file. The very first reason is very simple. You have to make use of the built-in functions which are already available. So those built-in functions prototypes will be available in the header. So we need the headers to be included whenever we want the built-in functions to be used. Another reason for us to have a header file included is sometimes we can try creating our own functions. We can create our own headers and we can let others use that header file or others use that function. So we have two reasons for having a header file written. One is to make sure you use the built-in functions, because built-in functions internally will be invoking with the operating system. So you have to include the header file for that. Another reason is to make sure we being the users are trying to create our own header files and we are trying to uh, uh, give it to others to make sure others are using it. Ma'am, is all the materials available in the LMS to reference purpose? Yes, so they all will be available. Now, please note the difference between a header file and a .c file. Okay, so header files will be with the .h extension. A source file will be with the .c extension. Now, header files are going to contain some functions declaration. So declaration means the statements which tell about the function. Okay. So for example, if I have to write any function, so assume I want to write a function which is having the return type as integer. Okay. The name of the function is fun and the function is taking two integers, int x comma int y. Okay, I want to write this function. So let us not concentrate on what to be returned in the function. I just want to write this function. Now I have to tell the compiler about this function's existence. For that I can just write the declaration of the function, which looks something like this. The return type of the function, name of the function, and the input types the functions take, terminated with a semicolon. So this is the declaration of the function. Okay. So, this is the fun function which is having a return type and it is also having the type of the input it takes. So this is the difference between declaration and definition. So this is called as declaration. You are just telling the compiler that there is a function called fun taking an input of type integer and returning an output of type integer. It is declaration. This is definition because after a function is called, what should be executed? You write it in a function. So inside this, if let's say I want to write int or let's say sum is equal to x plus y, something like this I want to do. So that is definition. So all declarations will be available in header files. All definitions will be available in .c files. Apart from that, header files also contains some of the definitions of the functions, some of the data types of the functions. Okay. So the header files contain the declarations and definitions. Along with that, the data type, some portable data types. And this header file can be used in more than one file. Okay, header files can be used in more than one file. Now coming to the definition. So they are going to have, if you take a .c file, which we call it as a source file, so it is going to have the functions and the variables definition written. Okay. So you will have the definitions of the variables written, and apart from that, so whatever are written inside the function, they are not shareable, or whatever is written in a .c file, they are not shareable. So you can see some macros, you can see some data types which are not shareable. So that's the difference between a header file and a source file. A very major difference is header files are going to have the declarations of the functions written. The C files, the .c files or source files are going to have the definitions of the function written. Okay. So there are two ways of including a header, one using angular parenthesis, the other one using double quotes. So there are two ways of including a header. So first one, we use angular parenthesis to include the header. So what happens if you include the header using angular parentheses is, whatever file you are trying to include will be searched in the standard path. So every device will have a standard path where the built-in header files will be available. So whenever you try including a header file using angular parentheses, the search for the file is going to happen in the standard path. So it searches for a file in the standard path. If the file is found, the header file gets included. If the file is not found, it gives an error saying that the file is not found. No such file or directory will be shown as a error. So if you are trying to include a header using angular parenthesis, the search is always happening in the standard path. But if you try including a header using double quotes, so that is a way of including a user-defined header file. So if we being the users write any header file, we include it using angular parenthesis. So when you try including a header using angular parenthesis, the search for the file will first happen in the present working directory, or wherever, whichever folder you are working, the search for the file will happen in that folder. And if the file is not found, it is going to be searched in the standard path also. If the file is not available in the standard path as well, it is going to give you a error that the file is not found. So whenever you try including a header file using angular parenthesis, the search happens in the standard path. And if you try including a header using double quotes, the search is going to happen in the present current directory or folder you are working. And if it is not there, it is going to search in the standard path. If it is not there in the standard path also, it is going to give you an error. So that is about the two ways of including the header. So whenever you are trying to include a built-in header, have a habit of including it using angular parenthesis. And if you are trying to include a user-defined header file, you can include it using double quotes. Okay. Next, whatever header files you take, they have to be included for only once. So whenever you take a header file, any header file you take, so they have to be included for only once. Standard path means it is like a dedicated path in the system where all of your built-in header files will be available. When the system was designed, when the operating system was being installed, there will be one path where the built-in header files will be stored. So that we refer it as standard path. Or I would say standard folder where the built-in header files will be available. Okay. So fine. Next thing is, whenever you try including a header file, it has to be included for only once. So whichever header file you take, it has to be included for only once. Now what happens if you try including a header for multiple times is, header files can have some data types written. Current directory means current working directory. You can call it as the folder which you are working. So that is called as current directory. So the folder you are working is referred as current directory. We refer it as directory rather than folders. Okay. So I was telling that headers have to be included for only once all the time, because header files are going to have some data types written, some macros written. So you will have multiple things written in a header file, and they always have to be included for only once. You cannot have an header included for multiple times. So to make sure the header is included for only once, we are going to follow something called as conditional compilation. Okay, so conditional compilation. So what this is going to do is, as if ndef of name. Okay, if ndef means if not defined. Okay, if ndef means if not defined. Okay. Why cannot work Windows 11 in i5 7th generation? So you have to check with the compatibility of the Windows 11. Okay, you please check it. Yes, I was saying that if not defined means if ndef means if not defined. So this is an approach we use to make sure the header is included for only once. Okay. So now what happens is, if I have to take an example, assume there is a header file which has some let's say some variables declared. So int x. Okay, this is what I have in a header file. So assume this is file.h. Okay. So what happens is, in your program, you will do something like this. Include, let's say, file.h, because it is a user defined header file, you will include it in double quotes. Now assume the same thing you will do it for multiple times. Okay. So what happens is, wherever the header is included, the contents of the header file gets replaced. So this gets replaced with int x. Okay. So wherever the header file is included, the contents of the header file gets replaced like this. Okay. So this gets replaced with int x. This complete thing also gets replaced with int x. This complete thing also gets replaced with int x. Now having the replacement done for multiple times will end up giving us an error. At some point of time, it will end up giving us an error. So I have to make sure the header is included for only once. So what I will do is, when I'm creating a header, I will write something like this. If not defined of a macro, I am going to define a macro and I'm going to endif. Okay. So endif. Now what happens is, first time when you are trying to include a header file, okay, so what happens, it is going to check whether a macro by the name macro is defined. If not defined of macro, so as of now I don't have a macro defined, so it is false. So sorry, if it is true, because I don't have a macro defined. If not defined of macro is true, I am going to define a macro, I include the x and I end it. So that is what I am doing for the first time of headers inclusion. So I am checking if a macro by the name macro is not defined, condition is true, you are going to add a macro, then you are going to include x and you are end it. Second time when you are trying to include a header file again, If not defined of macro will be condition false. So you will not add all of this for another time. Again, when I say hash include of file.h, so it is going to check if there is a macro defined by the name macro. So if not defined of macro will be condition false. Again, I will not end up adding it for another time. So even if I try adding a header for multiple times, if I have my header written this way, I will make sure header is included for only once. So that is the way to make sure header is included for only once. Okay. So what is a macro? Macro means it is like a variable. Okay. So it is a variable. It is a pre-processing stage variable. Okay. So macro is like a pre-processing stage variable. So it is a name given for a constant. So that is a macro. In case of macro false, second time, we can take true. What happens? No, it will not be true because you are including the same header. It will never be true. So because it is not true, so it is not going to get added again. Okay. Macro is user defined or predefined. So it's a user defined. Okay. So it is something which is user defined. So it is a name given for a constant. So that gets executed at the pre-processing stage itself. Okay. If you want to see more, so you can observe here. A macro is nothing but a simple identifier which gets replaced by a code fragment. So we have two types of macro. One is object like macro, the other one is function like macro. So this is how we write a macro. Hash define, symbolic name, constant. Okay. So hash define buffer size 1024. There is a macro I'm defining called buffer size representing the value 1024. So wherever I see a macro called buffer size in my program, it gets replaced with 1024. So that is something called as object like macro. A macro which is representing a constant value. An object like macro is the one which is the way of giving a symbolic name for a constant value. Okay. So that is nothing but a macro. Like define pi, it can be anything, so you can write any macro. Okay, so for any macro can be written. Okay, so a macro means whenever you want to write a macro, you use a preprocessor directive called hash define. You give the name of the macro, you also give the value the macro is representing. Okay, so we have a macro name written as buffer size, and this macro represents the value 1024. Okay, the buffer size is the macro representing the value 1024. Throughout the program, wherever buffer size will be seen, so it gets replaced with 1024. Okay, so why do we use macro? It is just to save some of the space. So if you are just taking a variable to store one value for only once, we don't need a variable. You can just go with the macro. Okay. Now this is our argument type macro, a macro which takes arguments also. So we call it as argument type macro. So here I'm showing you one example, set bits num comma position. Okay. So I am calling a macro called set bits with the value 0 comma 2. So it is a function like macro. I'm calling a macro called set bits with the value 0 comma 2. Okay. The definition of the macro is, if you can see here, the definition of the macro says num or with one left shifted for position times. So num here is representing the value 0. Position here is representing the value 2. See, set bits, num receives 0, position receives 2. Okay. So this num is receiving 0, position is receiving 2. So I'm doing num or with 1 left shifted for position times. So num is 0 here. Okay. And position is 2 here. Okay. So the macro is been replaced. So the definition of the macro says num or with 1 left shifted for position times. Num collected 0, position collected 2. So 0 or with 1 left shifted for 2 times will be replaced. Okay, so that's a macro which is going to get replaced at the pre-processing stage. This is again a macro and this is a multi-line macro. Every line of a macro has to be terminated with the backslash. Okay, every line of a macro has to be terminated with the backslash and there should be nothing written after a backslash. So every line of a macro should be terminated with a backslash. Now wherever a macro is called, it gets replaced by the definition. So I'm passing to the swap macro num1 and num2. This whole thing gets replaced at this place. Okay, I have a macro called swap with num1 and num2. So here if you see, okay, the replacement happens like this. So it is actually, if you observe here, it is int temp is equal to a. So a is equal to b and b is equal to temp. Okay, so wherever a is there, it gets replaced with num1. So wherever b is there, it gets replaced with num2. So this is num1, this is num2, this is also num2. Okay, so int temp is equal to num1, num1 is equal to num2, num2 is equal to temp. So that is how you write a macro. So int temp is equal to num1, num1 is equal to num2, num2 is equal to temp. So macros are always meant to be written in a single line. Whenever you are trying to write a macro in multiple lines, each of the line of the macro has to be terminated with a backslash. So I am having a backslash written at the end of each line of the macros definition. Okay, so can a macro be considered as a function? No. So macro is like a name given for a constant. Okay, so it's a name given for the constant. So what happens in a macro is it gets replaced. Okay, so it gets replaced in case of a macro. You cannot call it as a function. So macro has two types. One is object like, the other one is function like. It looks like a function, but it is exactly not a function. So macro can be used as function and also for defining variables. Yes, it looks like a function, but that is not a proper function. Can this as define be considered as a prototype of the function? No. As define is a way of declaring a macro. Okay, you don't call it as prototype. So wherever the macros call is seen, it gets replaced with the definition of the macro. So that is what I can say. So it is like a very big topic to be discussing about macro, but this much for the internship, I think is sufficient. Now you have already some predefined macros available. Okay, so if you can see, Double underscore file, double underscore is a macro which represents the file's name. Hash define mybit port C, also an example of macro. Yes. So wherever hash define is seen, it's a macro. So double underscore file, double underscore is a predefined macro which represents the name of the file you are working. Double underscore date, double underscore represents the date in which you are working. Double underscore time, double underscore is the macro which represents the time you are working. Double underscore func, double underscore represents the function you are working. And double underscore line, double underscore represents the line you are working. So these are like the built-in macros which are already available. So a file represents, yes, they are standard macros. They already are going to have a predefined value showed. So file represents the file you are working. Date represents the date on which day you are working. Time represents the time you are working. Func represents the function you are working. And line represents the line you are working on. So like at the you don't have to add it, so you just have to make use of macros. The value gets substituted by themselves. A percentage yes is a macro which is used to percentage yes is a format specifier which is used to print a string. Okay, so that is it, and this completes the C module. Is it possible to fetch the macro from a different file? No. So whatever macro you write, you can write it once. It is a global macro. When you compile, wherever a macro is seen, so it gets replaced automatically. So if you want to be fetched it from another file, the only option is you can write the macro inside a header and you can include that header file to whichever file you need the macro. Okay, fine. So this completes the C module and we are done for the basics, how much ever is required for the project on the microcontroller to be done. So the basics of C is what we discussed throughout this module, and I hope you people are clear with this. So this much of knowledge should be good to have the project done. So you don't have assignments provided. You may have to be taking some tests. So any information regarding will be made as an announcement through our LMS platform. So please check that, and you will be able to get through it. And how to swap without temporary variables, that is something you have to try. So it is possible without using temporary variables. You have to use arithmetic operators or bitwise operators. Okay. So your next module is going to start tomorrow. Your microcontrollers module will be started tomorrow. So this as a reference will be available for you. The slides, the PPTs will be available for you in the LMS. You can make use of it. Okay. So it should be available. If it is not, we will make sure to add it. Okay. And you should be able to use it. Okay, when you will start working on the project once you are given with an idea about it. So for that you have to go with the microcontrollers module also. So regarding any assignments or anything you want to know, so we will make an announcement on our LMS platform. You please keep an eye on the platform. We will make an announcement, and tomorrow is Friday, it's not Saturday, and class will still be there. Okay, it's microcontroller. So microcontroller is going to start tomorrow. I hope you enjoyed the C module. So please make sure you are taking the benefits of the microcontrollers module also starting from tomorrow. So thank you all and have a good time. All the best for your upcoming days. Thank you all.